Usually when we make a truth table, we get a combination of trues and falses. But there are a couple of special cases, and they have special names. A contradiction is a compound statement that is always false, and a tautology is a compound statement that is always true. We also have an implication, which is a conditional statement that is a tautology. Well, what about the statement, heads I win, tails you lose? Is this a contradiction, a tautology, an implication, or none of the above? In order to see, let's let heads be P and I win be Q. So how would we write this statement in symbolic form? Well, the first part, we might rewrite it as if heads, then I win. And the second part, we might rewrite as if tails, then you lose. Now the tricky part is how to connect these two together. Should we use the word and, or should we use the word or? Well, it's not possible to get both heads and tails on the flip of a coin, but it is possible to get heads or tails on the flip of the coin. So we want to write this as a disjunction using the word or. If heads, then I win, or if tails, then you lose. So what would that look like in symbolic form? Well, if heads, then I win, that's going to be if P, then Q. What about if tails, then you lose? Well, since P is heads, tails must be not heads, which is not P. And if you lose, then that means that I win, so you lose is the equivalent of Q. So we can write the second part as if not P, then Q. And then finally, we join these two conditionals together with or. Since we have two simple statements, we have 4 different cases to consider. Just like regular algebraic statements, let's go ahead and start inside the parentheses. Let's start off with P. P just alternates, true, true, false, false. Next, we'll fill in Q, which just alternates, true, false, true, false. In the second set of parentheses, we have not P. The negation of true is false, and the negation of false is true. So we end up with false, false, true, true. And then finally, we have Q. And again, that is true, false, true, false. Now we'll go ahead and evaluate the conditionals. Now remember that a conditional can only be false if the first part is true and the second part is false. So I'm going to go through and find all the places where the first part is true and the second part is false and put a false there. Here we have true, false, so this must be false. In every other case, the conditional is true, so we can fill in all the rest of the values with true. And then finally, the last step is to form the disjunction of columns 5 and 6. Remember, an or statement is only false if both parts are false. Well, in this case, there's at least one true in each case, so that means that we fill in true for all cases. Since we ended up with all trues, that means that this is a tautology. Is it also an implication? Well, an implication is a conditional statement that is a tautology. So the question is this a conditional? It's certainly a tautology. Well, the last thing that we evaluated was a disjunction. So that means that this statement is a disjunction. It is not a conditional statement. Therefore, it is not an implication. So even though it contains two conditional statements, overall it is a disjunction and therefore it is not an implication. But it is a tautology.